In this video, we are going to look at example 6 in section 4.4. So we want to calculate the integral from 1 to 4 of 10 minus 5x divided by the square root of x with respect to x. And here's a picture of that function graphed here. So what that looks like in terms of area, we want to compute the area under our curve from 1 to 4. Keeping in mind that when we compute this value, this area down here is going to show up as a negative. So you might think to yourself, should we be getting a positive number or a negative number as a result? All right, well, let's do some calculations and find that exact number. So you might be thinking that the structure of this integrand, this function here, is a quotient. We're dividing 10 minus 5x by square root of x. And we don't have a way of finding an antiderivative for such an integrand. Well, just like we saw in the previous example with a product, we can break this quotient up into two terms, where for each term we can find an antiderivative. So let's see how that's done. So we're starting with the integrand 10 minus 5x over root x. So that's equivalent to 10 minus 5x all times 1 over root x. Dividing by the square root of x is equivalent to multiplying by 1 over the square root of x. So we can distribute that 1 over square root of x into each term, which becomes 10 over square root of x minus 5x over the square root of x. All right, and similar to when we were computing derivatives of functions, when we're computing antiderivatives, if we have square roots over our variables, then it's helpful to rewrite those square roots as fractional exponents. So what would that look like here? So here we'd have 10 over x to the 1/2 minus 5x over x to the 1/2. We can clean this up even further by canceling and also changing these denominators to be x's with negative exponents. So that would look like we'd have 10x to the negative 1/2 minus 5. Nope, and we're running out of room here, so I'm just going to pause real quick, rewrite this down here so we have some more room. All right, so 10x to the negative 1/2, then minus 5x times x to the negative 1/2. So here we have a common base. So how to combine this two terms is to add exponents. So x has an imaginary 1 here. So 1 minus 1/2 would just give us a 1/2 exponent. So this is equal to 10x to the negative 1/2 minus 5x to the positive 1/2. So far we've done no calculus. We've just rewritten our integrand, our function inside the integral, as two terms with fractional exponents. So the question that we're investigating is, what is the integral from 1 to 4 of 10x to the negative 1/2 minus 5x to the 1/2 with respect to x? So take a moment, pause the video, and see if you can come up with two antiderivatives here for our two terms. And when you're ready, let's investigate together. So the structure of each term here is a power of x. So we can use that in an antiderivative for a power function. So that would look like 10x to the 1/2. Recall we want to add, if our function is x to the n, then the antiderivative would be x to the n plus 1 over n plus 1. So for us in this first case, n is negative 1/2. So we add 1 and we get positive 1/2. Okay, but we're not quite done yet because we still have to divide by the new exponent. So divide by 1/2, or equivalently multiplying by 2 if you'd like. Okay, so there's the antiderivative for the first term, and then similarly, the antiderivative for 5x to the 1/2 would be 5x to the 1/2 or 3/2 divided by 3/2. And using that notation, we want to evaluate this function at 4 and 1 and take the difference. All right, so clearing some room here. So let's compute that difference. So this becomes, we want to just stay really clean in our work here. 10 times 4 to the 1/2 over 1/2 minus 5 times 4 to the 3/2 over 3/2 minus, and I'm going to use parentheses because I'm going to subtract an entire difference. So I don't want any minus signs to drop. So then we have 10 times 1 to the 1/2 over 1/2 minus 5 times 1 to the 3/2 over 3/2. All right, so let's take a look at what we have here. So we can clean this up a little bit. So dividing by 1/2 is the same as multiplying by 2. So this becomes 2 times 10 times 4 to the 1/2. That's the square root of 4, which we know is 2. So there's our first term, minus, and again, dividing by 3/2 is the same thing as multiplying by 2 over 3. So we have 5 times 2 over 3, which would just be 10 over 3 times 4 to the 3/2. Minus, now here a lot of things simplify. So anytime we have 1 in a base, no matter what the exponent is, our output is going to be 1. 1 to any power is 1. So what we have here is 10 divided by 1/2, which is the same thing as 10 times 2. I'll write that out just so we see it. So that would be 20. Then we have 5 times 1 divided by 3/2. So 5 times 3/2, divided by 5 divided by 3/2 is equal to 5 times 2/3. So that would be 10 over 3. All right, not bad. So now we get 2 times 2 times 10 is 40. We can consult our calculator for this one. 10 over 3 times 4 to the 3/2 is going to be 80 over 3. And minus, we have 20 minus 10/3. So if we do that subtraction, we can just carry it out here. So we get 20 plus 10/3. That's just bringing that negative sign into each term. So now we can kind of combine some terms to help us simplify. So 40 minus 20 would give us just 20. Then we have minus 80/3 plus 10/3. All right, so we're dealing with a lot of thirds. That just gives us 20 minus 70/3. And if we carry out that fraction, that is going to give us negative 10/3. So our final answer here is negative 10/3. So the total area under this curve between 1 and 4 is a net negative. So we see more area on the bottom, or on the negative direction of the x-axis than compared to the positive direction. Awesome, nice work, everyone. This problem did include some tedious algebra, but it's good practice for us to go through these types of problems where we are paying attention to detail, where we have a lot of things that we're sorting out. And it's just good to take your time, take it slow, rewatch videos as needed, as you'd like, and keep up the hard work.